Example 3. Bone density test using table A-2. A bone mineral density test can be helpful in identifying the presence or susceptibility to osteoporosis, a disease that causes bones to become more fragile and more likely to break. The result of the bone density test is commonly measured as a Z-score. The population of Z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these test results meet the requirements of a standard normal distribution. Now, the graph of the bone density test scores is shown in the figure. A randomly selected adult undergoes a bone density test. Find the probability that this person has a bone density test score less than 1.27. So here's our graph. Here's the mean of 0. We want to find the area or the probability that is less than 1.27. Since it's a positive z-score, we're going to use the positive z-scores. Now note that the following are the same because of the aforementioned correspondence between probability and area. Now, the probability that the bone density test score is less than 1.27, the shaded area shown in the figure above, and we need to find the area in the figure to the left of 1.27. So we want the area below 1.27, and in this case, table A2 provides the cumulative area from the left. So let's take a look at that. So we're looking at 1.27. So using our graph, our highlighter here we have 1.2, and then the 100th place represents 7. So if we take a look at the value that we get for the area, or the probability, is 0.890. So you can see that the desired area is 0.8980 rounded. And because of the correspondence between area and probability, we know that the probability of the z-score below 1.27 is 0.8980. So that means that this entire area you can see here represents 0.8980. And so the interpretation would be the following. The probability that a randomly selected person has a bone density test result below 1.27 is 0.8980, shown as the shaded region. Another way to interpret this result is to conclude that 89.80% of people have bone density levels below 1.27. And again, that's because you're multiplying 0.8980 times 100% to get 89.80%.